In this section, we're going to be covering sample proportions and the rules that go along with them. So just to refresh your guys' memory, in the previous section, I told you guys that proportions were basically percentages. They tend to have more of a categorical nature than anything. We are going to actually meet all three of these objectives in this particular lesson. So here are the formulas that we're going to need for this particular lesson. They should already be written on the handouts that I gave you guys. What this basically says is the mean of basically all of the p-hats will equal like the actual mean, and then over here if we plug in the p that we're given, the probability, and the number of observations, we can find a standard deviation. Now there are going to be two rules of thumb that you're going to want to follow. So the first rule of thumb is you're only allowed to use the standard deviation formula, the one that I gave you over here, this one. You're only allowed to use that when the population is at least 10 times as large as the sample. So for example, let's just say my sample happened to be the heights of 10 young women. Well, that's actually going to be an example that I'm going to be using later on. There are more than, so at least 10 times as large. So if I'm doing a simple random sample of 10 young women, basically times 10 would be 100. There's definitely more than 100 young women in the world. So that's an example of how you would use the rule of thumb, the first one anyway. The second one you only use if you want to do normal approximations, and if you look at it, it's not really anything new. We actually covered this in the last chapter. Basically you want the mean, n times p, to be greater than or equal to 10, and you basically want kind of like an inverse version of it. This is almost like standard deviation from the previous chapter, except for in the previous chapter standard deviation had a square root here. So essentially it looks like standard deviation. As long as both of these exceed 10, we're good to go. Now here's the first example that I'm going to cover today. This basically talks about first year college students, and they want to know how many of them apply to other colleges other than the ones they're attending. Now they're doing a simple random sample of 1,500 first year students, and they want to know what is the probability that the random sample of 1,500 students will give a result within 2 percentage points of this true value. Now this question is actually a precursor to the chapters that are going to follow this one. They're going to be asking a lot of questions like this, and it's going to be something to do with something called a confidence interval. I'm not going to get too specific about what confidence intervals are and all that, but I will talk about what this answer means in context when we get to it. Now I know that you guys would probably like to see me do this by hand, so I've prepared something so I can do most of it by hand, but if I were to write all of this out by hand, this video would be extremely long. So I am going to do like the main parts. So important thing is, we know our simple random sample happens to be 1,500, so that's going to be n. That's the number of the population, the sample that I have. And then we were also given basically the mean. We were told that was 35%, so basically we can just say that p hat is 0.35. Now if I want to actually calculate standard deviation using the formula that I gave you guys, this one right here, I have to first check the first rule of thumb. So this right here is me checking the first rule of thumb. So I have a sample of 1,500 students. I know that at least 10 times that amount is 15,000, and there are tons of colleges all over not only this nation but the world, so there's definitely more than 15,000 first year students that apply to different colleges other than the one they're attending. Now I'm not writing this out right now, I have it done ahead of time, but this is everything you're gonna see that's written here is essential. There's no cutting corners. So now that we've checked the first rule of thumb, we can actually plug in our numbers here so that we can get the standard deviation for this particular set. Now for this part here, the 1 minus p, that'll give us 0.65. If you guys want to skip having to write this part out and just point the 0.65 here, I'm totally okay with that. Nothing wrong with that at all. And then if you enter this all into your calculator, you get the answer is 0.0123. kind of funny, goes in that order. Now, rule of thumb number 2, we have to check that too. Rule of thumb number 2 only, we only have to check that if we're going to be using normal approximations. We were asked to find a probability, so the best way to find a probability with all of this would be to normalize it. So, first of all, let's do n times p. So that actually yields 525. And then if we do kind of like the inverse of it, inverse probability anyway, whoops. This gets us about 975, and then both of these are greater than 10. So check, we can normalize this. So first thing you're going to want to do is you want to standardize p. So your formula sheet doesn't actually have a formula like a written one for z-scores because they take on very many different forms. For this particular case, we're going to use something that looks like this right here. Now right here we would use basically mu. In this case our mu was 0.35, and then down here we would use standard deviation. Now we calculated this new standard deviation over here, so we're actually going to use this number. And then actually step 2 is to find the z-scores, so I'm just going to go ahead and erase this here. This is the step 1 was standardize it. So this is us standardizing it. Now I put down here z-scores. It says the question was, find the probability within 2% points. So if I draw a picture, by the way, pictures are mandatory. This is 0.35. Now within 2%, on the upper end, if I add 2% here, this is going to be 37. And on the lower end, it's going to be 33. So what I'm interested in is basically this area here. So I have to find the z-scores for both of these, and I have to use basically subtraction in order to be able to correctly find the answer here. So let's do the first one. So I'm going to start with my 33%. Now the cool thing about these being like equal distance from basically the mean is that when you actually do both of these should be the numbers that we get, the z-scores, should be very, very similar. Now in this case, we're basically going to have the same number, but we're going to have the positive and negative version of it. So that's step 2. And then on to step 3. For step 3, we're actually going to want to calculate the probability at this point. So I want to find the probability that basically my z-score is between these two numbers, that it'll fall between these two numbers. Now if you look on table A, when we do this value here, let's see if this will actually focus. When we do this value here, we get this as our answer. And then when we do this one here, we get about 5% as our answer. Now when you subtract those, you get a number that's roughly about 90%. Now I'm going to put right here, roughly 90% of all samples will give a result within 2 percentage points of the truth of the population. So what that means is, if we were to take a random sample of 1,500 students from any college or a collection of colleges, 90% of the time, the answer or the results would basically fall into this category here. So about 90% of the data will fall in here. So when we standardize this, essentially this works about 90% of the time. And again, this is kind of a